Guys, let's try to make this training more interactive as much as we can. We'll be making it more interactive. So the question is that how can we make it more interactive? To make sure that this training is more interactive, I would allow you, like all of you guys are allowed to sit unmuted. However, you can sit unmuted, but make sure that there is no background noise. You are alone in your room, then you can sit unmuted and you can actively participate in the class. So when I say actively participate in the class, which means that you always ask me the questions, you stop me, like have discussions. Having discussion is very important during the classes, so that things are clear to you, clear for others. Sometimes I might say that, okay, I will not give this answer now because we are going to cover this topic in next 15 minutes or an hour or so. I might say that, but do not stop asking questions. And one more thing, you can always ask questions at any point of time. You just go ahead and mute yourself. You have rights to unmute yourself. You do not have to raise your hand. Do not raise hands. I will not be checking your hands, or maybe if you put something in chat, I will not be reading that. Just go ahead, unmute yourself and start talking. Just stop me. Like you can say, you can simply say, excuse me, sir, I have got a question. So I will always, you are always welcome if you are asking the questions, because asking questions will make this session more interactive. We should try to make it more and more interactive as much as possible. So you guys are, all of you are free to ask questions at any point of time. Do not wait until I finish my topic. Just go ahead and ask the questions. So that's one thing that I wanted to inform you all. Second, now I'm going to display the list of topics that you will be covering. So as you know that we are covering SD-WAN, and for SD-WAN specifically, we have got a SD-WAN module training. So I'll take you through the ciscos.com first. And from there, we can see that which all topics they have included in their content. So you go to cisco.com, then go to learn, then go to certifications. Under certifications, you just have to go to CCNP SD-WAN, like say browse all certifications, and then go to CCNP and CCNP Enterprise. Under CCNP Enterprise, you should see the SD-WAN, and that is ENSDWI SD-WAN solution, including SD-WAN architecture, controller deployment policies, and security. Now just click on top of, like hover your mouse on top of 300.415 ENSDWI, and then it should give you the exam overview or exam topics. So now you can look at the exam topics, and accordingly you are going to cover things up now, right? So if you look at their architecture, so that's the first thing that we will cover, where you are going to learn about different components participating in Cisco SD-WAN architecture. And then once you are done with that, thereafter you would start the deployment, the controller deployment. So we will be installing the controller. We will be performing the controller deployment. Especially we are going to perform the on-prem deployment. For cloud deployment, I'll have a discussion. I'll hold a discussion with you, but will not be performing any lab for the cloud deployment. Once you are done with the controller deployment, then we will proceed further with the router deployment. So for multicast routing, there is a description that they have added now. Earlier it was not there, but now they have added this multicast support, the description of multicast routing in SD-WAN, but there is no lab. Then we have got the policies, that is section 4, and this is same as before. There is no change. And then you have got security and quality of service. So it is also same as before. And then finally, you have got management and operations. So basically, Cisco has divided this training into 6 different sections. So there are 6 sections in total. And the section 1, section 3, and 4 are most important because the weightage of those 3 sections is 60%. So section 1, 3, and 4 is very important. Each and every section is important, but these sections are going to be little larger than other sections, right? They have greater weightage. So you can also download this complete list of topics that you are going to cover during this training, and I'm gonna cover this this training this content over here, right, during this training. Also, I will open up the PPTs that I'm going to follow now, and you have got access to those PPTs using your portal itself.
So one question regarding this blueprint, uh, on which particular topic we have to perform the labs?
You will be performing labs for all topics, but initially we will cover the theory, right? So just a moment, I'll be back on my call. Just a moment. Give me a sec, please.
Okay.
So whatever we are going to cover in theory, for same we will be covering labs. But initially during the architecture, the first section, we do not have any lab, right? We only will cover some theoretical concepts. Like first we have to understand the solution, right? What it is all about. And then only we will start further. So your labs are going to be started from section 2. Right? If you really look at that content, right? So agenda, right? Architecture. So during this architecture explanation, like while explaining this architecture, we will not be having access to the labs. And also there is no need to perform any lab. But if you start with the deployment, that's where exactly you would be needing having access to your labs. So we are going to start performing labs from section 2, not from section 1. Is that clear now?
Yes.
Okay.
Yes.
So as I said, this training is divided into 6 different sections. And then if you look at the total number of labs that we are going to perform is, the number of labs that we will be performing 51. So in total, we will be performing 51 labs. And also you can look at here. So even performing labs also divided into multiple sections. Like if you look at first, creating a SD-WAN overlay and underlay in the network. So we will be interconnecting SD-WAN components. Then we will set up a root CS server. Then we will be initializing controller. We will be deploying the control components. Then next we will be deploying the managed routers. Then we'll start working on the templates for VHs and CHs bot. In template, we will cover like system template, banner, then VPN template, interface template, AAA, BFD, and all that kind of thing. At the same time, you will also cover your traditional routing like static, OSPF, BGP, IGRP kind of thing, the TLOC extension. Then right after that, you will start with the policies. And then when it comes to policies, then you have got like control policies, as well as you have got data plane policies. So we will be covering that. And we have got security policies. So application aware, firewall, IDS, IPS policy. So these all are the security policies, URL filtering, integration with Umbrella. And then cloud on ramp features for SaaS as well as for infrastructure as service. And finally, so wherever it is demonstration, which means that I'll be giving you a demonstration, right? And wherever we have got like implementation, which means that we will be implementing things. And then we have got day 2 operations, right? Finally. And that's the end of all labs. And that's the end of the training as well. So basically these many labs you will be performing during this training. Now, this is the lab environment that we are going to use here. This is the lab environment that we are going to use. It will be common for all of us. I'll be using same lab. You will be using same lab, right? So this is the lab architecture. So in this lab, like, let me explain it a little. I'm not going to explain it completely, but yeah, let me give you a quick introduction to this lab. If you look at here, you have got service provider, the internet service provider, as well as you have got the MPLS service provider. So there are two separate providers, right? ISP, internet service provider, and MPLS provider. So MPLS is like kind of private connectivity that you get between remote sites. Then you have got multiple remote sites, like site 1 is there. Then we have got site 2, and we have got site 3, right? So we have got site 1, we have got site 2, we have got site 3, and we have got this DC, right? We have got this DC. So in DC, we have got C edges, the Cisco edge router, right? And then we have got V edges across all other remote sites. So you can also see that some of the sites are dual CPE site. So when I say dual CPE, you have got two different managed routers. That's called dual CPE site. And then we have got single CPE site. So when it comes to single CPE, which means that you would have a single router connected to the WAN, like internet as well as MPLS. So we have got single CPE site, we have got dual CPE site, something like that. So accordingly, we will be building up the policies and you will be learning this SD-WAN technology. You have got control component, one vManage, one vSmart, one vMont in your topology. Connected to internet, and also it is connected to the management network so that you can have management access to all these components. And also these components will be reachable through the internet, because connected to the internet as well. We have got some non-SD-WAN routers, like non-SD-WAN routers. So we have got this non-SD-WAN router, and that's where you would be needing your traditional routing protocols to be implemented, such as OSPF, BGP, or maybe EIGRP. Although EIGRP is supported by CH only, so you will be deploying EIGRP in data center. But you have got everything in this topology. And also you have got the scenario for TLOC extension at site 3. So this site 3 is designed in such a way so that you would be needing TLOC extension. TLOC extension is one of the features that you would be implementing it during the training. So this site 3 is designed in that way. And that's it. So that's all about this topology, lab environment. If anybody has got any questions about the lab environment, Chandu, I see that you have unmuted yourself.
Yeah, the site one, are we assuming that VH routers, VH1 and VH2, are they in high availability like that, or like a kind of HSRP?
You will be deploying the VRRP. Only VRRP is supported by Cisco SD-WAN.
Okay, not HSRP, yeah?
No.
Okay.
So we will be implementing the VRRP, right, for high availability.
Okay, and also I can see some firewalls in this topology. Are we
It's not
going to
really
configure them
firewall. It's a router, but yeah, you can think of that. Okay, it is a firewall.
for netting purpose?
Not really for netting purpose. I have placed like firewall has its representation for sort of service chaining.
Okay, okay.
Although it is not a firewall. So you are not going to work on firewall, because here in SD-WAN training, we are not going to touch like ASAs or checkpoint or whatever, right? I have just added that component. It is a router basically, but I have named it as a firewall so that you are
Okay,
familiar that in case if you get into this kind of requirement, then how you would fulfill.
yeah, okay.
Yeah.
Thank you.
What's the difference between the C edge and the V edge?
The difference between C edge and V edge.
Yes.
Okay. I mean, actually, those are two different platforms, right? One is coming from Viptela. So V edge is from Viptela, right? And C edge is from Cisco. So the Cisco platform will be called, Cisco router will be called C edge. So let me tell you, this SD-WAN solution came from Viptela originally. It's not, originally it's not a Cisco solution, right? So there was Viptela, that was a totally different vendor, right? So just like Silver Peak. Nowadays, Silver Peak is part of HP. That is a different scenario, but earlier it was just Silver Peak, right? Similarly, the Viptela was a SD-WAN provider, right? Or SD-WAN vendor. And in 2017, Cisco acquired Viptela, and that's how Viptela became the Cisco SD-WAN. Now, a couple of months back, Cisco renamed the Viptela SD-WAN with or Cisco SD-WAN with Catalyst SD-WAN. So now it is Catalyst SD-WAN. So they have renamed it. So when I say V, so V was for Viptela, right? So when I say vManage, which means it came from Viptela because it's using Viptela OS, and still it is using Viptela OS. So when I say VEdge, which means VEdge will be using the Viptela OS, Viptela operating system. And we are still using Viptela operating system. Now, Cisco does not really recommend to use the Viptela routers. Why? Because Viptela routers have got limited functionality as compared to Cisco routers. But still, you would see that a lot of customers are using VIPTela routers. So when I say VH, those are VIPTela routers. When I say CH, those are Cisco routers. I hope that that answers your question.
Yes, thank you.
Yes, sir. Apart from that, will there be any differences when we are implementing the our configuration, doing the configurations
Between the VH
those
and
two
CH?
devices? Yes.
Yeah, absolutely. Why? Because VH is using the VIPTela OS and CH is using iOS XE. So the configuration command syntaxes, the configuration steps are totally different from each other, right? So the command syntax is going to be completely different for both managed routers. And even the features are different. The operating system is different, the command syntax is different, and even the features supported are also different.
Since that Cisco has renamed that VIPTela thing to Cisco Catalyst thing, will they test in CH environment like in the exam or in the VH commands only? For example, they will put some configuration and all, whether this
So
configuration
now
will
the
applicable or not.
complete focus on the CH devices only, right? Complete
Okay.
focus is Cisco is focusing on the Cisco routers only, not on VIPTela routers anymore, right?
Okay.
So even in exams, you would get more questions on CH, not on VH. But since the
Okay.
technology is common, it's just a matter of a list of some, I would say, list of some features, right? That CHs have got some more features as compared to VHs, right?
Okay, the concept should be same, but only
Yeah,
that we will see some
absolutely.
commands and difference.
Yes,
The VPN 0 and VPN 512,
everything will be
everything
same.
is the same.
Yes.
The
The
coloring.
VIPTela calls it VPN, and CH routers, on CH routers, we will call it VRF, right? So when I say
Okay.
VRF or VPN, it's the same thing actually.
Okay.
But on Cisco Edge routers in iOS XE, the VPN will be displayed as a VRF. Whereas
See,
in VIPTela OS,
when we are configuring these guys, vManage and vSmart and vBond, we used to configure that VPN 0 and VPN 512. Since it is renamed to Cisco Catalyst, again it will be changed here VRF kind of thing in vManage.
no,
I
they
mean,
are still using
CMA.
VPN.
Okay, even though they have renamed to Cisco Catalyst.
They have just rebadged it. That's it.
Okay.
The Toyota is selling the Maruti cars with rebadging, but the actual production is done by Maruti only, right?
Yeah, because I'm asking that question because in VEdge routers we will configure VPN and CEdge routers we will configure VRF.
So
So
even in
that's
on
why.
CH routers, it will be a VPN in terms of the template, but in backend, in command syntax, it will take it as VRF,
Okay, okay.
right? In templates, it is going to be same for both, whether it is VH or CH. The terminology will be same. Okay, so I see that couple of more people joined post. We had a quick introduction, like I see Kiran had joined after that, and then Muhammad Ajhar has joined, right?
Right, sir.
So I'll take your introduction in the end, right? Because the introduction was already completed. You joined a little late, and even Kiran has joined late. So I'll take your quick introduction in the end of this session, like before we end this session, right?
Sure, sir.
Ayotele, you were trying to unmute yourself. Looks like that you had the question. Go ahead.
Yes. When we start the controller deployment,
Mhm.
is it going to be CLI or GUI?
So whether you are deploying the controllers deployment in production environment or in lab environment.
During this lab.
I mean, see, what I'm saying is that in both cases, whether you are deploying the controllers in this lab or maybe deploying in production environment, in both cases, if you are initializing your controllers first time, you will have to perform some sort of configuration using CLI. Then only you will be able to onboard them. So there is a there is a configuration that has to be done using CLI only, that you cannot perform using GUI. However, if you are asking to Cisco to deploy the controllers on your behalf, so they have got their cloud operations team and they are using complete automation in backend. You just have to fill their form Like they will give you the link, user ID, password. You just have to log in. You have to put on that how many vManages, how many vSmart, how many vMon you need. You just fill in and submit. Immediately, all your controllers will get deployed. But they are using automation. We're not going to follow that way. In our lab, as well as if you're deploying the controllers by your own manually in your own environment, even in production, the process will remain same. Initially, you have to bring up your devices by putting some CLI configuration. Without that, you will not be able to add your devices. I hope that answers your question.
Yes, thank you.
Fine. All of you knows that we are going to start learning SD-WAN, right? All of you have joined this session to learn the SD-WAN technology, and that is great for all of you, right? To understand or to learn this new SD-WAN technology. But the initial question that I will ask each one of you or to all of you, why SD-WAN? Why it was needed? Why it is needed? Why customers are moving on SD-WAN? That's my question. So why SD-WAN? Why Cisco SD-WAN? Not only Cisco SD-WAN. Let's talk about the SD-WAN generic SD-WAN in general, right? Let's talk about in general why SD-WAN. Let's not talk about the Cisco SD-WAN initially. Obviously, we are going to learn about the Cisco SD-WAN, but the question is that why SD-WAN? Why this software-defined wide area networking? So let me tell you, the full form of this SD-WAN is software-defined wide area networking, right? Software-defined wide area networking. Why? Why SD-WAN? So
Something like a single pane of.
yeah, you're right. So point is that before we start with SD-WAN, we have to start with SDN. We have to think from SDN, right? And SDN stands for software-defined networking. So SDN stands for software-defined networking. And now we need to understand that why SDN is important. Why software-defined networking is important. Why it was introduced. Why everyone is talking about SDN nowadays, software-defined networking. And which all Cisco solutions are available under this SDN category. That's what we are going to discuss now. So whenever we talk about this SDN, basically it's a controller-based networking. It is a controller-based. So whenever you talk about the SDN, software-defined networking, which means you're talking about the controller-based networking, where you have a centralized controller. From that centralized controller, you are going to manage all your network, entire network, all of your devices. So you'd have a centralized controller to manage all your devices. And that's SDN, software-defined networking. And this is not something new. We have seen it, like we are seeing it from long time. Even in Cisco, this is not something new that they have started with, right? I don't know how many of you are aware with the Cisco security. In Cisco security, they had ASAs, right?
Yeah.
To manage
Yes.
ASAs, they had one controller, CSM, right? Cisco Security Manager. I don't know how many of you have worked or got opportunity to work on CSM, but
CSM or ASDM.
not ASDM. I'm talking about the CSM, Cisco Security Manager, which was kind of like centralized manager, right? So using that CSM, we were pushing the configuration on multiple ASAs at the same time. Like basically we were managing the ASAs from that CSM, although it was not a complete package. I mean, it had so many flaws, and that's why CSM got failed as well. Like it was not really adopted by the industry at large scale, but yeah, it was there. So it's not like Cisco is trying to define controller based networking, from a recent time. No, since long, Cisco tried to have this kind of like controller based networking, I would say. But point is, let's not talk about those older solutions and all that, CSM and all. Let's talk about this controller based networking, why it was important for us, or why it is why it was necessary for us to have this controller based networking. Let me give you one example. Let's say you are going to make some changes today, right, in your production environment. Obviously you make changes, right? So whenever you make the changes in production environment, I'm talking about here I'm having a general discussion with you, right? Let's not talk about the SD-WAN. Let's have a general discussion. So let's say you're touching 50 routers today, or maybe you're touching 50 switches, or maybe you're touching maybe 100 firewalls, or maybe you're touching, let's say, 10 load balancers, right? Maybe you're touching WLCs. And WLC is one of the perfect example of centralized or controller-based networking, right? To manage all your APs. Cisco had WLCs in place, right? And WLC was like one of famous product that they had, right? It became
Yes.
really famous, right?
Yes. Yes.
Point is that if you're touching 50 routers or 50 switches or 100 firewalls during your change, like you have a change which has to be implemented on all 50 routers or 50 switches. So you know that there is a process of pre-check and post-check, right? Pre-check and then post-check. So in pre-check, what you do is that you go to each router before making the change. You take the backup of that router. You check the iOS version. You check CPU utilization. You check memory utilization. You check routing table. You check summary of the routing table. You check neighbor table, and you basically record those outputs somewhere, right? And then post-check will also take place. So the pre-check and post-check is going to take more time than implementing the change on the router. Let me tell you. And then later, people started this controller-based networking. So when I say controller-based networking, people started using some scripts to perform this pre-check and post-check. I don't know how many of you have used that. I've used it a long time ago, like in 2000. I still remember in 2014, 15, I used to have the Perl script for ASAs. So before I was touching like 100 firewalls, 100 ASAs, I was running that script, and that script was going to each and every ASA and was capturing the required information. And once it was done, then after I was pushing the change onto firewalls. So it has been there from long time, this centralized networking. But just imagine, forget about scripting, because scripting is again controller-based networking, right? Forget about scripting. So if there is no script and you need to perform pre-check and post-check on 50 routers, 50 switches, or more than that, or maybe 100 firewalls, or even more than that, how much time it is going to take? Just imagine. I don't think that a single change window would be sufficient for you to perform all your all your changes, right? You would break your change into multiple windows, right? Like you will pick multiple change windows. Let's say you said, okay, let's complete these 10 routers today, and for next week we will pick another set of 10 routers. For next week, we will pick another set of 10 routers. This is how you would do it. So you really had a pain, actually, especially with this pre-checks and post-check. So we needed kind of a script, which is again controller-based networking, right? We needed a centralized controller where we could just provide our instruction that go to all these 100 devices, take the backup, and also record these outputs, the output of these commands. We were providing a list of commands. That's where the SDN was needed. Software-defined networking was needed. The controller-based networking was needed. Scripts were needed. Not only that, I don't know how many of you have gone through it, but I assume that all of you would agree with this statement as well. How about SNMP strings? Let's say one of your SNMP string got compromised. Let's assume that, right? Your cybersecurity team, they came across that the SNMP string has got compromised, and now it is time to update the SNMP string across all the devices. And let's say you are having 5,000 devices, all like routers, switches, firewalls, load balancers, whatever, right? In total, you have got like 5,000 network equipments, network devices, and you need to update, you need to update this SNMP string across all the devices now. How would you do that? I still remember we did it somewhere around 2013, 14, I believe so. And I still remember that all team, right, especially the operations team, was engaged for that. And 24/7, they were doing the same thing. They were logging onto the devices and they were updating the SNMP communities, SNMP strings. So making changes on 5,000 devices, updating that SNMP string took really long time. I still remember that it took like maybe 3 days actually. And it was a single command that needed to be executed across all the devices. Like one command was needed to be executed to remove that string, and one other command was needed to be executed to update with that updated string. But still, it took so long time. So we had so many pain points, and I'm just explaining the pain points now. So I have explained you the pain point of the pre-checks, post-checks, also updating the SNMP community string. Now I'll give you an example of the remote sites as well, or maybe data center, where I will include a couple of more pain points, and then I will come back to this software-defined networking. So let's assume that you had a data center, centralized data center, where you had like maybe an internet connection from multiple ISPs. Also, you had MPLS connection from multiple providers in DC. And then at your branch offices, you had MPLS connections. So like you had branch 1, you had branch 2, you had branch 3. That's how most of the networks were designed earlier. So if remote branch user was needed to access the application hosted in your data center, they were going through the MPLS, right, to the data center. So everything was backhauled into DC. Everyone was backhauled into the data center, right, using MPLS. And even if this user needed internet access, so first you were backhauled into DC, and then from DC you were going to ISP, internet service provider, and in same way you were coming back. But this is how you deployed or you designed your network in old days. Even you would see that kind of architecture in today's world as well. Although things are getting changed now with SD-WAN, but you can still find that the organizations are using this sort of. So now, let's say there was MPLS provider 1 and MPLS provider 2, right? For all branches, the MPLS provider 1 was primary and MPLS provider 2 was secondary. Just like that, right? Primary, secondary for the purpose of failover. What about if management changed their mind and they said, hey, you need to make sure that provider 2 is the primary now for all our remote sites. What will you do now? You'll have to go to each vantage router where, so when I say vantage router, these all are vantage routers, right? Behind vantage router, you can have so many other things like layer 3 switches, maybe some other routers, access points, the layer 2 switches. Right? I'm not talking about those devices. I'm just talking about the vantage routers where your WAN connections have got terminated. So if you needed to modify policy and even you were using, like, let's assume that you were using the BGP, border gateway protocol, right? So ideally you would update the BGP policy for that, like especially in this type of requirement, right? You would update the BGP policy, like route policies are there, route maps are there. So in BGP, you have got so many different attributes that you were using for path manipulation. So sometimes you were using local preference, sometimes you were using MED, whatever, right? But you were using some BGP path attributes, right, to achieve your objective. So if you have got like 1,000 branches, right? Just imagine you have got 1,000 branches, and across all 1,000 branches, you had the same requirement where you have to update your primary or secondary provider, right? So you need to make sure that your traffic is going to data center using the updated primary provider, right? Or via MPLS provider 2. I don't know how many of you have gone through this situation, right? I have gone through, like personally, I went through all these situations, right? Where we needed to log into all these vantage routers across all the remote sites, and we needed to update the BGP policy so that the desired path could be selected or could be followed, right? So again, it is a pain point. Why? Because it is going to take so long time to update this information. Seriously, it will take so long time. If you have got 1,000 sites, how many people would be available in your team who knows BGP? Only those people would be able to make changes then. So you would have limited number of resources who are proficient with BGP, right? So it's a pain. Now I'll give you one more example. I'm just giving you some pain points, right? I mean, I'm explaining pain points where we had issues actually, right? Because then only you would be able to understand the real use case of the SD-WAN or SDN. I would say SDN, software defined networking, right? Now, I don't know how many of you have gone through this situation, but if you look at what about if unknowingly someone, let's say you had the ACL on WAN facing interface, right? You had an ACL. Unknowingly, you modified that ACL and then you lost remote access to the device. And ACL was applied on both of the WAN facing interfaces. So none of the interface is working now. How can you overcome with that problem? How can you fix that problem then if you are stuck with that kind of situation? Like you had a WAN facing, you had an ACL applied on WAN facing interface, fine, but you made some unexpected change within the ACL, and that caused connectivity loss. So you lost remote access to your devices. Since you lost the access to the remote devices, so how you can regain the access of those devices then? You will have to wait for some field engineer to visit that site, right? So field engineer will have to visit that site, and then field engineer will give you the console access, and then you will make some changes, and then again you would your remote access will get restored. That's how it is going to work, right? Then what about if you are let's say you are trying to bring up a new site? I'm giving you another example, right? You're trying to bring up a new site now. How do you do that? So ideally, first, cabling has to take place, and then you will order all the devices that are going to be placed, right? Especially, let's talk about this VAN edge router, because behind VAN edge router, sometimes you would have just layer 2 switches. That's it. So you would order this VAN edge router. That VAN edge router will get delivered at your site. You would ask some field engineer to go and to give you the remote access. First, they will have to power on the device. Then we'll take the console access, and then we'll share the screen. You will make the configuration, or you will provide some initial configuration in flash drive to your field engineer or over an email as an attachment to your FE field engineer. Field engineer will copy paste that configuration onto device. If connectivity doesn't come up, again you would ask your field engineer to share a screen with the engineers who are sitting in headquarters or somewhere else, right, at remote site, and then engineer will perform troubleshooting. So it was kind of like difficult. It was difficult to onboard a new site actually. I would not say that it was impossible. We did that. We are still doing it, right? But it is difficult. It takes time. It's a time-consuming process. So that is another pain point. Now, routers had one more issue. The old VAN edge routers, like they had no capability of application awareness. Like if you see, we were using BGP as a routing protocol, and we were building policies. Like sometimes we were also doing the load balancing, that for certain prefixes, the MPLS provider 1 would be preferred, and for certain other prefixes, the MPLS provider 2 would be preferred. But you were doing this sort of thing based on layer 3 information. The routers never had visibility to the applications. So application aware routing was not possible. But now in SD-WAN, the VAN edge routers have got the capability of the application awareness. And even you can set like, okay, for this application, I want to choose this circuit or that circuit. That's doable. So these all were the pain points. I can give you more examples. I can keep giving you more and more examples. And not only for managed routers, if you think about the switches, the Catalyst switches, right? I'm talking about the Catalyst switches like 90, 200, 9300, 9400, or maybe earlier we had 3750, 3760, 3500 series. If you talk about the Catalyst switch, you're making some changes on switches, then you have to log into all switches. Although we had a concept of stacking, but in case of stacking, then you needed to install all the switches at same place, right? Then only you could configure the stacking, because the stacking was making all your physical switches into a single logical switch, and then you needed to configure, or you needed to run commands only on one switch, and then that would take place across all the switches in that stack. But point is that it is not always possible to have all the switches at same place, right? I mean, that's not possible. So point is that we had same issues with switches as well. Like if you need to add VLAN, in most cases you use VTP more transparent, right? You don't use client server combination. So if you're using transparent, then you have to add the VLANs across all the switches. You need to modify NTP server IP, not only SNMP community string. Don't forget NTP. Even sometimes you may have a requirement to update your NTP server IP address, right? Sometimes you would be updating the radius server IP address. So you can have these small requirements, but that was taking so long time, right? For you to update settings across the domain, across the organization. So we needed sort of solution where we could have a centralized controller and then apply your change to that centralized controller, and then rest of the things will be taken care by that controller. You go and, like, let's say you needed to update the SNMP SNMP string, community string. You go to that centralized controller, update that string, and then push change across all your devices, and boom, your change is implemented across all the firewalls, 100 firewalls, 1000 firewalls within couple of, I would say, minutes or seconds. That's why this SDN, software defined networking or controller based networking, was needed. So this is not only for routers, this is not only for switches, it is for all devices. Even nowadays, you would see that SDN, software defined networking, is equally applicable for firewalls, right? All right. Now, when we talk about the SDN solution within Cisco, so within Cisco, when we talk about the SDN, software defined networking, we have got multiple options here, right? We have got, like, at higher level, in general, you have got SD-WAN. You have got SDA using DNAC. You have got ACI for Nexus switches. And these all solutions are part of this SDN, software defined networking. So SD-WAN is one of the component of SDN when it comes to Cisco, right? There are some other technologies also exist, as I mentioned here. You can see SDA. Remember that this SDA or DNAC is mainly useful for Catalyst switches. You can manage only Catalyst switches using SDA. In ACI, you can manage all your Nexus switches. So basically, ACI is for data centers. For remote site, for headquarters, you'd be using DNAC to manage your Catalyst switches. And to manage all your managed routers, you have got SD-WAN, software defined wide area network. Now within SD-WAN, Cisco has two solutions. One is Cisco SD-WAN, the Catalyst SD-WAN. That is what we are going to learn. The other one is Meraki SD-WAN. Now remember, we are not covering Meraki SD-WAN during this training. We are only covering Catalyst SD-WAN or Cisco SD-WAN or Viptail SD-WAN, I would say. You can call it Viptail SD-WAN, you can call it Cisco SD-WAN, or you can call it Catalyst SD-WAN. Now it is Catalyst SD-WAN. That's the most latest terminology, right?
Any differences that Cisco SD-WAN and Meraki SD-WAN?
Even if there are, I will not discuss them here.
Okay.
Because we are covering Cisco SD-WAN, right? We are not covering here Meraki SD-WAN. Can you please put yourself on mute, Sasidhar? Yeah, thank you. So obviously there are differences, but we are not going to cover them here. Why? Because Meraki is not part of this training. Only Cisco SD-WAN is part of this training. So only we are going to cover the Cisco SD-WAN here, the Cisco SD-WAN solution. Now remember in
Sir,
SD-WAN, yes.
Sir, hello. Sir, is Meraki included in the certification syllabus?
No, it is not.
Okay, thank you.
Yeah. So this SD-WAN, in this SD-WAN, Cisco SD-WAN, all you are going to manage your managed routers. So if I go back to your topology, remember in SD-WAN, you are going to manage only managed routers, the WAN facing routers. So if you have got like internal layer 3 switches like this, or firewalls or non-SD-WAN routers, you cannot manage them in SD-WAN. So in SD-WAN, all you are going to manage is managed routers. And managed routers are those routers which are connected to the transport, which are connected to the service providers, whether that is an internet provider or the MPLS provider. But in SD-WAN, you have got a controller called vManage. From vManage, you will be managing only managed routers. So if you want to manage your managed routers using software, then use SD-WAN. If you have got Catalyst switches, you want to manage them from a centralized controller, then use DNAC, DNAX, DNA Center. You can also build SDA fabric for that. If you want to manage your data, like in data center, if you have got Nexus switches and you want to create a fabric and many more things, then use ACI. So basically, if you look at, Cisco is giving you a complete solution, because you would have a data center. For data center, you have got ACI. For managed, because managed routers will be placed even in data center, right? Across all remote sites. So to manage all your managed routers, then you would have SD-WAN. And for managing your lane switches, like Catalyst switches, right? You would have DNAC. So Cisco is giving you a complete solution when it comes to the software-defined networking. So for switches, you have got DNAC. For managed routers, you have got SD-WAN. And for data centers, Nexus switches, you have got ACI. So you have a complete solution. One more thing that I would like to explain here. The SD-WAN technology that we are going to learn here, we are always going to take examples from a enterprise customer perspective. Even if you look at this topology is created based on an enterprise customer. So like you have got one enterprise customer which has got data center, which has got a couple of remote sites. And for this customer, you will be implementing SD-WAN. Now remember, the provider, the ISP, within the provider network, they can also implement SD-WAN. And you would hear this sometimes, that the Geo, like one of the service provider, right here in India, is using SD-WAN internally for their internal connectivity. So it is not always necessary, or it is not always right to make the statement that the SD-WAN will be used by the enterprise customers only. No, it can also be implemented by service provider in their network. But our topology is constructed in such a way where you are taking an example of enterprise customer. Okay, but remember that service provider can also get it deployed in their own network, because service provider will also have the connectivity, right, for its internal network. Then only it will provide connectivity for its customers, right? Remember nowadays, like earlier, today itself, I have explained you that, okay, this is how we used to have the network earlier on, right? Like we were having MPLS, and if MPLS was not available at some locations, then, and only internet was available, let's say, then we were depending upon the DMVPN, right? Remember? that in Cisco DMVPN was also so much famous. I don't know how many of you still remember that DMVPN, dynamic VPN, right? We don't use it anymore. Even let me tell you one more thing. The Cisco SD-WAN routers do not support the DMVPN anymore. Why? Because the DMVPN is going to be is getting replaced by the SD-WAN. So if you are having SD-WAN, then there is no need to have the DMVPN. So as soon as you activate the SD-WAN on your router, let's say your router is supporting SD-WAN now, it will stop providing support for DMVPN right away. So remember that in Cisco, routers supporting SD-WAN will not support DMVPN anymore or dynamic VPN. So earlier, like we had this kind of setup, right? So over the internet, we had like kind of IPsec tunnel or DMVPN, and then we had MPLS. MPLS was primary circuit. As a backup, we were using maybe this DMVPN kind of thing. And then all routers had their own management plane, their own control plane, their own data plane, right? All routers, you can see that. Now things have got changed. Users are getting more requirements nowadays. Why? Let me tell you. Applications are moving to cloud. Like nowadays, you can see that so many applications are available as a SaaS, right? SaaS based application, software as service, right? So when I say software as service, so I can give you a couple of examples here, like your Office 365, Dropbox, Box. These all are an example of Salesforce, right? These all are an example of the SaaS based application or software as service, right? So applications are moving to the cloud. And since applications are moving to the cloud, and if you are still using the old technology, like from branch using MPLS, you will go to data center, and from data center, you will go to internet. Because if your application is deployed in cloud, which means that your application would be accessible through the internet only. So if you have got a SaaS based application like Office 365, so from branch first you will come to data center using MPLS, and then from there you will go to internet. And that is going to take so long time. Obviously, I mean, not long time. I would say latency would be higher. So the performance will be degraded then. So basically, branch users should have the internet available at branch itself. So internet is moving towards the branch. Earlier, we had internet connectivity at data center only, and your internet was secured by the firewall then. But now internet edge is moving to the branch. Like branch itself would be needing direct internet access. You have the concept of infrastructure as service. So if you have got infrastructure as service where a couple of applications are deployed, again, you would be needing internet access at your remote branch to have access to that applications hosted in infrastructure as service inside AWS or Azure, wherever, right? Now you have got the concept of IoT, remote users, guest users. Sometimes you do not get internet connectivity or MPLS connectivity at locations. And that's where you would be depending upon 4G LTE network. So earlier, routers were not supporting this type of connectivity, but now in SD-WAN, you would see that even you can install the SIM cards on your routers. So routers would support this 4G LTE type of connectivity. Customers are using the concept of multi-cloud. So trends are changing. Requirements are changing. So traditional way of networking would create so many problems then. Like the problems would be security challenges because the internet is moving to the edge. Insufficient bandwidth we had, limited app awareness. In fact, I would say it was not there, right? Higher cost, complex operations because you would be needing more employees, more resources to operate your network, and still there will be a poor user experience, right? The solution was SDN, software defined networking, where you divide, because earlier we had an infrastructure layer, that's where we had the control layer, that's where we had the application layer. Now things are different. You have divided them. You have divided all those layers from each other, right? And that's where the Cisco SD-WAN will come into the picture. So in Cisco SD-WAN, you have got set of control components, and then you have got the routers. Obviously, routers are still needed, also known as managed router. The transport is still same as before. Remember, the Cisco SD-WAN or any SD-WAN technology out there in the market, although so far we have got only vendor specific SD-WAN technologies, whether it is a Cisco SD-WAN or Silver Peak SD-WAN, or maybe it is your Juniper SD-WAN or whatever, right? Meraki SD-WAN. All these SD-WAN technologies are vendor specific technology, right? But one thing is common, that these all SD-WAN technologies are transport independent technology, which means that you can use MPLS, you can use internet, you can use 4G LTE, whatever you want. Why? Because your SD-WAN technology is a transport independent technology. So you can still use your existing transport. You can use Metro Ethernet, you can use layer 3 MPLS, you can use just broadband type of connectivity. So it's up to you what you want to use. But just keep in mind that SD-WAN is a transport. SD-WAN is a transport independent technology.
A question, please.
Mm-hmm.
Looking at this topology at the moment, for instance, we have a edge device connecting to a station, a remote site.
Mm-hmm.
If we are connected via MPLS and it comes to the HQ and it goes out through the firewall, it seems protected. But if you are connecting directly to the internet, like the SD-WAN, this SD-WAN, you have the option of the MPLS, the internet, or the 4G. Using the internet or the 4G, wouldn't that bring some additional security features?
It would bring some security challenges, right?
Yes.
It would bring some security challenges. And to fix those challenges, obviously, all the SD-WAN providers are now providing the security features along with that, along with SD-WAN features, right? Like especially in Cisco, we have got some security features which would be available on your router itself. So you don't really have to install a separate firewall for that. On a router itself, you can get the firewall feature. On a router itself, you can enable URL filtering, IPS, IDS, even furthermore, SSL decryption. And also you can integrate your managed routers with Cisco umbrella. So if you are going to internet direct, so before going directly to the internet, first your traffic will go to the Cisco umbrella or Zscaler, like cloud-based proxies or SIG, secure internet gateways, right? So first your internet traffic will go there, and over there you can enforce your internet policies or SIG policies, right?
Okay. All right. Thank you.
So that's that. But by looking at this topology or this diagram here, you see, right? The vSmarts, right? If you look at the vSmarts, these are the control components, the control plane components. So basically you have offloaded the control plane functionality from your managed routers to a centralized control component, which is vSmart here in Cisco SD-WAN. So in Cisco SD-WAN, the vSmart, also known as controller, the control component or control plane component, right? Now Cisco has renamed it from vSmart to the Catalyst SD-WAN controller. So they are calling it just controller, right? Now they are calling it as Catalyst SD-WAN controller, whereas vManage has been renamed as Catalyst manager, the SD-WAN manager, Catalyst SD-WAN manager, the vBond, the Catalyst SD-WAN validator. So they have renamed vBond with validator. They have renamed vManage with manager. They have renamed vSmart with controller. I will show all those terminologies. You don't have to worry about that, okay? But point is that in SD-WAN, the control plane functionality has been offloaded from managed routers to a centralized vSmart. Now, this would help to reduce the complexity of the control plane functionality. How? Earlier, you had control plane functionality available on each and every router. And let's say you were running BGP as a routing protocol, and you needed to update some policies in BGP. Then you needed to log into each and every router manually and to modify the policy there. right? However, in SD-WAN, you're going to have a centralized control plane. So if you are looking to perform sort of route filtering or path manipulation, you don't have to log in onto managed router. No, you just go and log in onto vSmart, modify your policy, you're done. Now that policy would affect all the, can affect all the remote site routers or managed routers. So you would have a centralized control plane. And obviously it is going to give you a lot of advantages by having a centralized control plane here, right? It would reduce a lot of complexities for you. As I mentioned, you need it to perform sort of route filtering for a couple of sites. You go, define the rule, define the policy on vSmart and done. Boom. So you are making changes at one place, but it is affecting multiple sites at same time. Also, you have got the concept of the templates, the configuration template on the vManage that you would be creating. So if you want to make the configurations onto your managed routers, you go and create configuration templates on manager. That is your management plane. So you have got a centralized management plane now. So from that management plane, you will be managing all your other components. Like from vManage, you can push changes, you can push configuration onto vSmart, you can push your configuration onto validator, which is vBond. You can also make the configuration changes onto your managed routers. And everything will be done from the vManage, because vManage is kind of manager that would give you the GUI access, graphical user interface access. So from vManage, you would be making all the changes. So let's say you needed to update the NTP server IP across all the managed routers, or you needed to update the SNMP string, or you needed to modify, you need to perform some sort of route filtering or whatever, right? You are going to perform that from vManage. You don't have to log into each and every router individually. No, forget about that. So SD-WAN is going to make your life easier, a lot easier than before. And let me tell you one more thing here. Between remote sites, like here at down, you can see that at remote sites, obviously you would be installing the physical routers, right? So obviously in cloud, you will be installing the virtual routers, but at physical locations, you would be installing the physical routers. You can see that they are establishing an IPsec tunnel or a secure connection between the sites. You can see that green one, right? So let me tell you, no matter that what type of transport you are using, whether it is MPLS, Metro Ethernet, kind of layer 2 connection or internet connection. In internet, you have got internet lease line, or you have got maybe the broadband connectivity. No matter what type of transport you are using, the IPsec tunnel will get established over the any transport, whether it is 4G LTE. The IPsec tunnel will get established between the remote sites, and that would get established automatically. You don't have to do anything for that. Even there is no troubleshooting actually, except troubleshooting your IP connectivity. If you have got IP connectivity between remote sites, then IPsec tunnel would come up automatically. You don't have to make that large configuration of phase 1, phase 2, define pre-shared key. No, you don't do anything manually. Everything would be done automatically. And this secure connectivity between remote sites over any type of transport would come up automatically. That all things are going to happen automatically. You are not going to implement the tunnels and all those all sort of things manually here. Okay. Although I'm not going to explain you everything in a single day or in a single session. Obviously, we have a lot more to learn. We'll keep learning that. We'll keep deep diving, right? But that's all I wanted to cover in today's session. If anybody has got any questions, go ahead and mute yourself, ask questions. If not, then we will proceed further tomorrow. Anyone?
Hi, sir. Can you please explain, sir, vBond again?
vBond is kind of validator, right? So basically, we have got so many different components here. If you look at there, and I have explained none of them. That I will explain tomorrow, because tomorrow I'm going to talk about the architecture. So if I talk about the architecture, which means we are going to cover each and every component here. Like vManage, as I told you, management plane, right? vSmart is a control component, which is going to act as a control plane. Validator. So if I talk about the vBond, which is going to work as a validator, which means it will be validating. So vBond is kind of first point of authentication for all of the components. So whenever you power on any component, first it goes to vBond and will ask for the authentication that, hey, can you authenticate me? If device is a valid device, then authentication will get completed. And then your validator will provide other information to that component, like the information about the vManage, the information of the vSmarts, that, hey, this is the vSmart, this is vManage, these are the IP addresses, go there and talk to them now. So that's what validator does, right? So we will cover each and every component here, that what is vBond, what is vManage, what are their functions, what is vSmart, what are their functions, what is managed router, what are their functions, and how many different types of manages you have got. That is also important question that we will cover tomorrow, right, sir?
Okay, sir. That's fine, sir. Thank you.
Any
Sir, you said
yes,
something about the tunnel forming automatically, the IPsec tunnel, the
yes.
pre-shared key. What if you want to use something like the SSL?
Actually, it uses SSL.
It uses
I will show
SSL.
you. Yeah, it will be using SSL, not SSL exactly, but TLS. So at some places it will be using TLS, and at some places it will be using IPsec. Okay. So for data plane connectivity, it will be using IPsec, whereas for control connections, it will be using the TLS tunnels.
The TLS. Okay. Okay.
Because security is major concern, right? So we always have to make sure that all the connections are secure connections, and all the information getting exchanged between different components is getting exchanged securely. So
Yes.
that's very important.
Sir, you were referring about fabric. Is that referring to the connectivity between vManage and Vantage routers?
I'm sorry, say it again. What type of?
You're talking about fabric, right?
Yeah, I'm talking about the fabric.
What is that actually? Is it
Fabric
referring
is
to
nothing but it is a virtual networking. It is a virtual networking between remote sites. That's fabric,
okay.
right? The virtual connectivity or virtual networking between remote sites. Like remote sites are interconnected to each other, but physically those are not interconnected, right? Virtually those are interconnected,
Okay.
isn't? So that's called fabric.
And these, the WAN technologies like 4G, MPLS, the T1 or the Ethernet connections, where they are connected actually? Is it to the Vantage routers?
So those are transports.
Yeah,
Whatever you have, yeah, those are the transports, right? Or WAN technologies.
Mm-hmm.
So yeah, all WAN connections will be terminated on your Vantage routers.
Okay.
Or maybe
and this,
you can get them terminated on non-SD-WAN router, and then further you can make a connection to the SD-WAN router. That is also possible. But ideally, all your transport side connections will get terminated onto Vantage routers.
Okay. And this vManage, is it like a router or something which has a?
No. It is a VM. It's a virtual machine, right? Which gives you the GUI access, which gives you the GUI access, graphical user interface, right? So you would be accessing vManage using your browser, and from there you will be doing everything. You do everything from vManage actually.
All right.
That's the only device that you access through the graphical user interface.
Understood.
No other devices will be accessible through the graphical user interface.
Okay. All right. And what series of routers would these Vantage routers be?
That is something that you would discuss when we cover the Vantage routers.
All right. Got it. Thank you.
All right. So that's it for today. And yeah, let's continue tomorrow.
Like yesterday, there was one example on ACL, right, where we would get logged out in legacy this thing, right? How is it overcome in SDN or SD-WAN?
I mean, see, you are asking now technical stuff, that how SD-WAN is working. That we have not started yet. So I would suggest to wait until we get started with the SD-WAN, that how to deploy things, because this question is more related to that how to deploy that thing, right? Like just in case if the ACL has got applied on WAN facing interface, then how it is going to overcome that problem. So basically there is a like, just to answer your question, although we are going to perform that in future, but just to answer your question, there is a concept of rollback, right? So for example, if you applied some sort of ACL and which caused the connection loss, right, between Vantage router and the control components, then your Vantage router will roll back the previous configuration and will reestablish the connection with the controllers automatically. You don't have to do anything for that. So if accidentally some configuration was applied, that caused the connection loss. So it's not like every time there will be a rollback. No, the condition is applied. If connection was lost with the controllers, then only Vantage router can perform rollback. Now, if something other happened, but connection is still available between managed router and the controllers, then obviously you can go back and you can make the configuration changes from the controllers, isn't?
Okay. Thank you. Thank you so much.
So we already discussed the agenda of this training and the labs that we are going to cover. Also, I had a discussion around this topology that we are going to use throughout this training. So that is also something that we have already discussed. The solution overview, as I discussed, the traditional network and the challenges that we had with traditional networking. I don't know how many of you understood that well, but yeah, I mean, I gave a couple of examples of the pain points that we had with traditional networking, right? And then I came up with SDN, software defined networking. That's where I discussed a couple of solutions provided by Cisco, like SD-WAN, SDA, and then ACI. And then I told that I explained that we are going to cover only SD-WAN thing, right? Not the complete SDN architecture provided by Cisco, right? So we are only going to cover the SD-WAN thing, right? So that is something that we already discussed. And today we were supposed to get started with the Cisco SD-WAN architecture, like the different components participating in Cisco SD-WAN. And we gonna cover all those components separately today, right? Individually. And I will discuss their roles and responsibilities in Cisco SD-WAN architecture. And again, it is a theory, right? That I'm going to cover. Later, we will be performing labs, right? But today there is no I mean, we are not going to cover any lab. Why? Because we are going to have a discussion around the architecture, that how it is going to work. And then later we will be proving it by by performing labs, right? Okay. So we covered this PPT yesterday. If you look at here, the Cisco SD-WAN, the features of Cisco SD-WAN, right? Or I would say the services provided by the Cisco SD-WAN, right? So if you look at the services provided by Cisco SD-WAN, so first, the routers, you know, your routers can be physical, also can be virtual. So you get the virtual routers, which you could deploy in the virtual environment, which means that you have got clouds, right? Cloud technology that we are using a lot nowadays. Customers are using a lot nowadays. So in cloud, you can deploy your virtual routers, and then physical routers is for the physical locations, right? And redundant management, right? So you can have on-prem management as well as in cloud. So you can deploy your control components. So there are many controllers, right? We discussed them yesterday, like vSmart, vManage, vBond. Although Cisco has renamed them now. Let me show you those naming conventions, right? Or the updated names, right? So that you are more comfortable with those new names along with the older names, right? So let me open up this. So if you look at here, so as I told you before, earlier we had a vManage, but now it has been renamed as look at this. vManage has been renamed as Catalyst SD-WAN Manager, right? And then vBond, Cisco vBond has been renamed as Catalyst SD-WAN Validator. The vSmart has been renamed as Catalyst SD-WAN Controller, right? So they have renamed those components, but the functions are still same, right? I mean, they haven't changed the functions. So the function of all these components is still same. And this renaming took place from version 17.12.1a and onward. So the most recent version is 17.13. That's the most latest one. But in our labs, we are using 17. I mean, this is iOS XE, right? This is iOS XE version. But if you look at the Viptela OS version, then this is 20.12. 20.12. I will discuss that later, but all I wanted to explain you that Cisco has renamed their components. vManage is now manager. vBond is now validator. And vSmart is now just controller. That's it. Let's come back to the PPT. So as I said, that you can deploy your controllers on-prem, which means that you can have some sort of hypervisors like ESXi, or you could use KVM, right? For on-prem deployment. But when it comes to cloud, then you can use AWS, you can use Azure. That's where you could deploy your control components, right? Your controllers. In Cisco SD-WAN, it also comes with zero-touch provisioning, especially for the managed routers. So for managed routers, you get this feature called zero-touch provisioning. So when I say zero-touch provisioning, the meaning of this feature is like you don't touch your router. So when I say you don't touch your router, which means that you don't take the console access of your router. All you have to do is you rack and stack your managed router, post doing rack and stack, make the cable connections, and leave it. That's it. That's all you need it. And it will be deployed automatically. And that's called zero-touch provisioning or zero-touch deployment. And that is supported by Cisco SD-WAN. Not only by Cisco SD-WAN, even if you take an example from other SD-WAN providers, they are also supporting same. Even nowadays, your broadband routers that are getting installed at your home are also supporting the zero-touch provisioning. Also, there is a separation of management, control, and data for scaling, right? So you have, like Cisco is using distributed architecture for data plane. You have got data plane devices. I have got control components for control plane. For management plane, you have a different component, and that I will discuss later, right? I mean, in next couple of minutes. You get choice of topologies with point and click. So you just have to select that which topology you want to use. Do you want to use full mesh connectivity between remote sites, or you want hub and spoke connectivity or partial mesh? The default behavior of the Cisco SD-WAN is to give you full mesh connectivity between the remote sites. So full mesh connectivity will be provided by the Cisco, but then you can change it, right? You can change the topology. Also, flexible connectivity with any WAN technology. So you can use broadband connectivity. You can use 4G LTE. You can use MPLS. You can use Metro Ethernet. Use whatever you want. You can save money as well at same time. Because if you don't want to use internet lease line, you want to rely on broadband, fine, you use broadband. That is supported at remote sites. Also, it supports secure segmentation by the help of VPNs or VRF. As I told you yesterday, even yesterday, somebody asked this question. If not, when I do remember that somebody raised this question, and then I explained that the VPN and VRF is same. Like in Viptela operating system, we call it VPN. In iOS XE, we call it VRF. Right. So without using VRFs or VPN, like you cannot deploy the SD-WAN. In SD-WAN, creating VPNs or VRF is mandatory. So secure segmentation is supported there. So which means that for each department, you can have different VRF or VPN. And by default, no routes will be moving from one department to another department, which means from one VPN to another VPN, or you call it VRF. Since routes will not be moving from one VRF to another, then how come or how you can expect traffic to move from one VRF to another VRF? So that is also not supported. So obviously it is going to perform secure when it is going to provide secure segmentation, right? And it will give you like end-to-end segmentation, like cross the sites. Only intra VRF communication will be allowed, right? But in case if needed, and you needed like inter VPN communication or inter VRF communication, that is also possible. It's not like technically it will not be possible. It is possible, but by default, no routes goes from one VRF to another VRF. Therefore, data will not be going from one VRF to another VRF. But yes, we can do that. Like we can configure inter VRF communication or inter VPN communication. We can get this implemented if needed. complete visibility from single pane of glass. So there is a component called vManage. There is a component.
Excuse me. Regarding this VPNs and VRF, for example, in site 1, for example, if I configure VPN 10, in site 2 also I should configure only VPN 10?
Then only communication would happen. If not, then communication will not be allowed, as I told you, right?
Okay.
Only intra VRF communication is allowed, intra VPN. So if you
That's,
want your
it's
remote
kind of
sites
like
to,
we need to have like a VLAN. It's kind of VLANs.
you can think of in any way, right? But point is that I'm expecting you, all of you, to have certain knowledge about the VRF, some prior knowledge around the VRF. Point is that only intra VRF communication will be allowed between remote sites. So if you are using same VRF across same VPN, which means, right? If you're using same VPN across all your remote sites, your users can talk to each other. If your users are in different VPNs or VRFs, then they can't talk to each other. Simple as that. So you must create same VPN across all sites if you want your all lane users to talk to each other. If you want some sort of segmentation, like sometimes you would have different requirements, like you have got corporate users, you have got PCI compliant network, or maybe HIPAA compliant network, right? And you have to create different VRFs for them, right?
Okay, thanks.
So then we have got single pane of glass. This is vManage actually, or SD-WAN manager, right? You get GUI access to this vManage. Then you have complete visibility of your network from this device. So when I say complete visibility, so not only you do monitoring from there, right? Not only you do monitoring, but also you do everything, right? So when I say everything, which means you can design your network, you can create a design on vManage, right? Then you can make the configurations, like you can perform implementation. And also you can perform troubleshooting, and also you can perform monitoring. So it's like all in one type of thing. And that's why we call it single pane of glass. And that's vManage. So even you don't require any third-party monitoring tools, like earlier we used to have them, right? Like QRadar and so, at least for manage routers and your control components. Why? Because you have got vManage for same purpose. It's doing same. Critical traffic redirection with application aware routing. So as I told you, even yesterday I had this discussion that earlier, like traditional routers never had visibility to your applications at layer 7, right? Traditionally, routers were responsible to forward your data based on layer 3 information only. Like packet came in, the router will read the IP header, will perform lookup for destination IP in the routing table. If it is available, will forward the packet. If not, then it will simply discard the packet. That's what it was doing. But nowadays in SD-WAN, the routers have got capability of doing routing at application layer. So routers will have visibility to your applications now. So when traffic is coming in, router can easily identify that, okay, this traffic belongs to YouTube or Facebook or whatever, right? And since router has got that capability, which means that on router, you can also define the policies that for YouTube, I want to use this circuit or that circuit. For Facebook, I want to use this circuit or that circuit, right? For SIP, session initiation protocol, that ideally you use for the voice over IP. For SIP, you want to use MPLS. So you can use MPLS for that traffic without modifying your routing table. So you can define the policies based on your applications. So that kind of visibility it has got now. Also,
sorry, a quick question about the vManage. You said you don't need your third-party SNMP like the PRTG or SolarWinds, but can it still work with it?
Yeah, it can, because you can still integrate your other third-party monitoring tools, you know, with by configuring SNMP. So that option is still available. It's not like that's gone away, right? It is still there. But point is that you don't need that, right? But if you have got some sort of NMS that you wanted to integrate with your network, with your routers, you can still configure the SNMP community strings.
Okay. Thank you.
Then we have got like secure data plane connectivity as well as control plane security, right? With IPsec and DTLS tunnel. Even I brought up this topic yesterday. So all the connectivity, whether it is between the remote sites for exchanging data, so that's called data plane connectivity, that would be secured by IPsec, or the connection between managed router and the control components like vManage, vSmart, and then vMon. That connection will also be secured by DTLS. So all the connections are going to be a secure connection because security is mandatory, right? It's a mandatory component. So you can't compromise with security, right? So in SD-WAN, all the connections that routers are going to form, are going to build, will be secured by either IPsec or DTLS. And that I will explain later that where it will be using IPsec and where it will be using DTLS. SD-WAN technology, Cisco SD-WAN is ready for cloud. And for both, for software as service, like if you have Office 365, Dropbox, Box, Salesforce, like that, you can integrate your SD-WAN with those SaaS-based, software as service-based applications, right? So if you have got like multiple circuits on your managed router, and then those circuits can take you to the SaaS-based applications. So you can ask your router to monitor the performance of available links. And you can instruct your router to use that link which is performing best at the moment. So your lane users would be accessing these applications from a best performing link. And even you can integrate it with the infrastructure as service. So let's say you have got an infrastructure hosted somewhere in cloud, maybe in Azure or AWS. So you can integrate your on-prem managed routers with infrastructure as service with your cloud. So even in cloud, you can install your managed routers, the virtual managed routers. And that's why you have got that option as well, the virtual routers, right? So virtual routers would be needed if you want to deploy them in your cloud. So it is a cloud ready technology. Enhanced routing functionalities with overlay routing. So yeah, overlay routing would be done. So I don't know how many of you are comfortable with DMVPN. But I'm expecting that since all of you are working professionals, so you must have heard DMVPN in past at some point of time. And some of you must be having some working experience over the DMVPN as well. So in DMVPN, there is a protocol called NHRP that works in overlay, right? Without NHRP, DMVPN cannot work, right? Or MGRE will not work. So for overlay routing, we have also got a dedicated protocol here, which is called OMP. And it is a Cisco proprietary protocol. Earlier, it was a Viptela proprietary, but now it is Cisco proprietary. Post Cisco acquired Viptela, right? So now we call it Cisco proprietary protocol. And that does overlay routing. So OMP is overlay management protocol, right? And it does not only perform routing, but also it does many additional tasks. Right? So I will discuss that later. So as I told you that when it comes to SDN, then within Cisco, we have got multiple options like DNA. So basically, we are going to focus on SD-WAN, right? Foundation of Enterprise WAN. That's where we are going to focus. Now, if we talk about the architecture, I told you in the beginning that we have got multiple components participating in a Cisco SD-WAN, right? And remember that in Cisco SD-WAN or in SD-WAN, only you are going to manage your managed routers, not all. Like in data center, behind your managed routers, you might have layer 3 switches, you might have firewalls, normal routers, the standalone routers, or I would say non-SD-WAN routers. You can't manage those devices using vManage. No, that's not possible. Using vManage, only you can manage those managed routers which are supporting the SD-WAN, right? So only SD-WAN only devices participating in SD-WAN can be managed through the vManage. So if you have like your firewalls or layer 3 switches. So for layer 3 switches, Catalyst layer 3 switches, I told you that you should use DNSC, DNS Center. If you have got Nexus, then use ACI, right? So in SD-WAN, using vManage, you can manage only managed routers, whether those are hosted in DC or in cloud or in campus, at campus or in the remote branches. Or maybe in Soho, small office, home office, right? So vManage has been renamed as Manager. You know very well, right? I already brought this up, right? vManage is Manager now. vSmart Controller is just Controller now. The controllers, right? And then vBond is the validator now. Manage is still Manage, right? So these all are the components participating in your SD-WAN architecture. So remember that Cisco is using the distributed architecture. Ideally, if you take an example from other SD-WAN provider, like if you take an example from Silver Peak, right? So if you talk about the Silver Peak, in Silver Peak, you have a centralized component, which is acting as a management plane and also acting as an orchestration plane and also acting as a control plane. So like all in one. So in Silver Peak, you get only one component that works as everything. If that goes down, then everything goes down. So in Cisco, it's not like that. In Cisco, you have got like different components having different roles and responsibilities. So in case just one component goes down, there is no impact on any other component then. So we are using distributed architecture in Cisco SD-WAN, right? So we have got vManage, one component, vBond, another component, vSmart controllers, other components, right? Remember, vSmart controllers are part of the control plane, or you can also call them as control plane components. So vSmart controllers are also known as control plane. And the vManage is called management plane. vBond is also known as orchestration plane. Now, what is the meaning of that? We need to understand that, right? We need to cover all these components individually. Like, what is the roles and responsibilities of vManage? What are the roles and responsibilities of the control plane? What are the roles and responsibilities of the vBond? And finally, we have to talk about the managed routers. One more thing that I would like to tell you is that when it comes to the control components, these all components are going to be virtual components. So if you are looking to purchase a new vManage and you are asking Cisco that, hey, give us the hardware, what they will do, they will give you the UCS server and they will ask you to install the vManage on top of that. There are no hardware devices, right? There are no hardware devices when it comes to the vManage, vSmart. However, there is an exception. There is an exception for vBond, right? The vBond can be virtual as well as it can be a physical device. So vBond is exception here, right? Across all the control components. Now, why I made this statement that vBond can be physical or virtual? You know why? Because vBond is not it's not a separate device, basically, right? vBond is a router. It's a managed router actually, running with Viptela OS, not IOSXC. Okay, so it's a managed router running with Viptela OS. So it's a managed router. On a managed router, you have to execute a command to tell it that, hey, you're not a router anymore. Work as an orchestrator or work as a vBond or validator. You know, now Cisco has renamed it as validator, right? So it is a managed router running with Viptela OS. Now, since router can be virtual or physical both, therefore vBond can be virtual or physical. But why would you spend that much money for vBond? Because it is just an orchestrator. Like it helps two components, or it helps components, different components of Cisco SD-WAN to talk to controllers. That's what it does. It is not handling user data. So if it is not handling user traffic, direct user traffic, if it is not participating in data plane, then what is the need of having a physical managed router configured as a vBond? So it's better to use a virtual managed router then, right? So vBond can be a physical, but not really recommended, right? You can have a virtual managed router running with Viptela OS, right? And then you can use it as a vBond or validator. Right. Other than that, like for vManage, there is a virtual machine only that you can deploy either in cloud or maybe on top of ESXi or KVM, like you would be needing some sort of hypervisor. And same goes with vSmart. Then vAnalytics is also there. You can see that, right? vAnalytics is also there, which is a SaaS-based application offered by Cisco as an optional. So it's an optional, it's not mandatory component, right? It doesn't do anything in SD-WAN. Right? Like if it comes to the troubleshooting or making configuration, the only thing that vAnalytics does for you is to create interactive reports. So if you're generating reports, then you can use vAnalytics. So it will give you interactive reports. It will generate those interactive reports, and then you can present them to your higher management to showcase that that much amount of bandwidth is already being used at headquarters or DC or maybe in a specific branch. And this is the most used application by the lane users. If that application is the business application, then yes, you would keep it allowing. If it is not, then you might ask customers or maybe you might ask security engineer to block that application. So basically you can plan your network based on the reports generated by the vAnalytics. That's what it does.
vAnalytics only for data transfer which is occurring between the edges, like only IPsec data or DTLS connection also?
All. Mainly you will be generating report. You will be generating report for the actual traffic generated by the end users, not DTLS tunnel. Because DTLS is just handling the control connection. That's it. It's not handling user data, right?
And also, will it collect that syslog or health checks of the edge routers?
No. See, vAnalytics is a SaaS-based application which does not talk to. Can you mute yourself, Chandu? Yeah. vAnalytics will talk to vManage using REST API, and then your managed routers are responsible to export their analytics to the vManage. So all managed routers will be responsible to export their information to vManage. And then this vAnalytics will import that information from vManage using REST API. So it's not working based on syslogging.
Okay, it will be integrated with the vManage and its SaaS application.
Yes.
The SaaS applications means where it will be hosted, like a Cisco cloud or any third-party cloud.
That I can't really make any statement on. That is something that Cisco can answer, right? That where exactly they have hosted this application. They would say that, okay, they have hosted in Cisco cloud, but technically there is nothing like Cisco cloud. So either they must be hosting this application either in AWS or Azure.
Sir, in case any third-party API need to configure on the means, if I have any third-party monitoring or analytic tool in my on-prem, Then if I want to integrate or if I want to export data using that third party, so what would be required in the vManage?
Nothing. See, from my SD-WAN perspective, I don't know that what you need. You have to tell us what you need. If you are a third-party monitoring tool, let's take an example of ServiceNow, right?
Yeah.
You're using ServiceNow. So if ServiceNow is being used, right?
Yeah.
ServiceNow needs to be integrated, then you need to tell us that how you want your ServiceNow to work. Like we can integrate the ServiceNow with the vManage using REST API. And also, if you want us to configure like kind of SNMP string, I can also get it done.
Okay.
We support as a vManage as a control component. This is the only component that supports the REST API. And there are different API calls that you can make. A lot of API calls you can make for different purposes. There will be different API calls. If you want, I can give you those API, and then you can make those API calls from ServiceNow to fetch specific information from vManage.
Okay, sir. Okay, got it, sir.
Yeah. So I will come on that point as well. You don't really have to worry about that. Point is that we are using the distributed architecture where we have different components here, right? Like vManage, which is a management plane. We have got vBond, which is again orchestration plane. Then vSmart, which is kind of control plane. So we have got like multiple control components in SD-WAN architecture, right? vAnalytics is just an optional component, and it does not really help you to make any kind of configurations or troubleshooting or kind of monitoring. No. The transport is still same as before. Even I had this discussion with all of you yesterday that there is no, the SD-WAN is transport independent technology, right? SD-WAN is transport independent. So no matter that what type of transport you are using, MPLS, internet, 4G, LTE, broadband, whatever, right? And then you have got the managed routers. Managed routers will be placed in data center, maybe in cloud, or maybe at your physical branch. And that is the reason that managed routers could be virtual or physical, both, right? Between managed routers, between remote sites, there will be a secure data plane connectivity, which is going to be an IPsec tunnel, and that I will discuss in here, in next couple of minutes. Now let's talk about all these components individually. Let's get started with the management plane first, which is your vManage. So in management plane, you have got vManage. Also, you call it manager now, right? It has been renamed as a SD-WAN manager. Now this vManage is going to work as a single pane of glass for day 0, day 1, day 2 operations. So when I say like day 0, day 1, day 2 operations, which means that from design to implementation, which is deployment, to troubleshooting, and then monitoring. And you can also call it like monitoring and troubleshooting, right? So for everything, you will be using this vManage. You would always have the GUI access to your vManage. So when I say GUI access, which means graphical user interface, so you would have a GUI access to vManage, like you will use your browser, and using browser, you will log in onto your vManage, and then you will perform everything from there. You don't have to go to any other component once those are onboarded to your vManage. Like once all the devices are added to your vManage, thereafter you do everything from vManage. vManage would keep monitoring all the components. So if one of the component goes down, then it will be displayed on vManage that one of the managed router or vSmart or vBond is down, is currently down. Right? So it will be doing everything, right? You want to configure your managed routers, you want to make some configuration onto managed router, you will be doing it from vManage only, right? And remember that because vManage is, we are doing everything on vManage, right? So which means that vManage must be able to pull the configuration from vBond, right? And also it should be able to push the configuration onto vBond. Same goes with vSmart, same goes with managed routers, right? So for that purpose, it uses netconf. Earlier, we used to have like SNMP, but now netconf is being used there, right? So it will be using netconf there, right? So remember that vManage is going to use netconf to talk to vWAN, to talk to vSmart, and also to talk to manage router. And netconf is nothing but it is an advanced protocol of it is an advanced version of SNMP. I would say that. So vManage is not using SNMP there by default to talk to other components in this architecture. It is using netconf there to talk to vSmart, to talk to vBond, and also to talk to manage router. Then REST is also supported by vManage, and that REST API could be utilized for the purpose of integration between the third-party monitoring tool or ticketing tool with your vManage. I just gave you that example. Like ServiceNow could be integrated with vManage, but for that integration, you would be using REST API, which all REST APIs are supported by vManage that I will cover in the end of this training. I'll give you a complete list of API documents, right, supported by vManage. So for different purposes, there will be different API calls, and then based on your requirement, you can call them out, right? Then vManage is also supporting the multi-tenancy, right? Which means you can use a single vManage, you can leverage a single vManage for multiple customers. And that's the meaning of multi-tenancy, right? So multi-tenancy is supported by vManage. Now remember that multi-tenancy is not supported by all components, but yes, vManage is supporting that, right? So like if you are MSP, so when I say MSP, which means managed service provider, such as Orange Business Services, British Telecom, Cisco itself, maybe Accenture, HCL, Wipro, Infosys, and many more. So these all MSPs are providing SD-WAN solution to their customers, right? So there will be sometimes there will be customers, which are not really able to manage, or they can't really bear the cost of the vManage, because see, vManage is that component that would be using most hardware resources. So let me tell you, to deploy just one vManage, you need 16 virtual CPUs, 32 GB of memory, one hard disk of 20 GB, another hard disk of minimum 500 GB, and only SSD is supported. So that many resources would be needing, minimum, that many resources would be required for vManage to work. And that is for single vManage. If you are using a cluster, let's say you are deploying 2 or 3 vManages just for redundancy purposes, then just assume that how much of resources would be needing. And then cost will be higher then. Then why would customer go over or migrate over to Cisco SD-WAN then from traditional networking? So for small customers, MSPs can offer like multi-tenancy on vManage. Like single vManage can be utilized for multiple customers. Centralized provisioning, you are going to provision all your components from vManage, and you would see that once we start lab, you would see all the policies, templates, everything, all the configuration will be done on the vManage. So if you are making, configuration, if you are creating configuration templates to make the configuration onto different components like vBond, vSmart, manage routers itself, vManage itself, so you would have to create the configuration templates. The policies would be needing to create to configure kind of route filtering, path manipulation, and even to implement data plane policies, like where you can have like application aware routing or DIAs and so forth. So all those things will be done on vManage. Your troubleshooting and monitoring will be done by the vManage. The software upgrades, like if you want to upgrade the software of any component, including vManage itself, and manage router, vBond, vSmart, all can be upgraded from vManage. It also supports role-based access control. So when I say role-based access control, which means that you would have different team members or different teams, like you have got level 2 teams, you have got level 3 team, you have got level 4 team. And now you don't want to provide the same level of access of the vManage to all of your teams. You want to provide some restricted access to level 2 team, and then some restricted access to level 3, and then full access to level 4 teams. Now, how can you do that? So for that purpose, it has got a feature called role-based access control. So you can create different groups, different roles with different roles, right? You can say, okay, this user group, can detach the devices from the template, but cannot create the templates. This user group can activate, deactivate the policies, but cannot edit the policy, right? So that way you can define the role-based access control. So that is supported by vManage. And as I told you, it supports REST and netconf both. Highly resilient. Why? Because it uses Viptela OS. So remember that all the control components, whether it is vManage or vSmart or the vBond, all of them will be using Viptela OS. So when I say Viptela OS, the latest version is, so basically in Cisco SD-WAN, there will be two different types of operating systems that you will be using. One is called Viptela operating system. The other one is called Cisco IOS XE. Now, Cisco IOS XE with SD-WAN capability is applicable only for VANEDGE router, which comes from Cisco, only for Cisco routers, right? But Viptela OS is applicable for all controllers and also for Viptela edge routers. Viptela edge routers. That's where you will be using this Viptela OS or Viptela operating system, right? Now, the current version, the latest version is like in Viptela, it's 20.13, whereas in when it comes to Cisco IOS XE, then that is 17.13. So the OS version is starting with 20, which means it will indicate that it is a Viptela operating system. And Viptela operating system is built on top of Linux. Like the kernel is Linux. The kernel of Viptela OS is Linux. And if the kernel is Linux, then you can call it highly resilient, right? So this highly resilient keyword or this terminology will be used not only for vManage, but similarly, it is applicable for vSmart and the vMont. Why? Because all these components are using Viptela operating system, and Viptela operating system is using the Linux kernel. In our lab, we are using 20.6 version of Viptela OS on all components, vManage, vMont, and vSmart. Even when it comes to the VANEDGE router, you have got vEdge router. So on vEdges, we are using 20.6, whereas on cEdge, we are using 17.3 in our lab, 17.3 in our labs. That's IOS XE version with SD-WAN capability. So that's vManage. So you would always have the GUI access to your vManage, right? vManage can be deployed in cloud, can also be deployed on-prem. So if you are looking for on-prem deployment, then use some sort of hypervisor like ESXi or KVM. Also, you could deploy them into Azure or AWS environment. Also, you could ask Cisco to, like I will come to that point later, right? Now let's talk about the control plane components, which is vSmart.
A quick question about the vManage.
Mm-hmm.
What happens if the vManage goes offline or it goes down? Will this? I believe there should still be
Only
communications
impact would
between.
be that you would not be able to make any changes. Rest will keep working.
Sir,
Okay? If vManage goes down, that's why we are using the distributed architecture here, right? Just a moment, right? Let me complete my explanation. We are using distributed architecture. Therefore, if vManage goes down, there will not be any impact on vBond or vSmart. So if you have some, routers already participating in your topology, vSmart's participating in your topology. Now vManage suddenly went down. Let's say due to any reason, right? It got crashed or whatever. There will not be any impact on your existing connectivity or any other component. The only impact would be that now if you want to make any configuration changes, you can't do that. You want to modify the policy, you can't do it. But whatever is running, it will keep running. There will not be any impact on existing connectivity. Make sense?
Yes. Thank you.
Suman.
Sir, in case for managed service provider, if we manage means if we want to upgrade the vManage, will it be affect the
All
customer?
customers.
All customer, right?
Of course.
Okay. So
And
in that case,
customer will not have capability to upgrade the controllers then.
Right.
Right.
Even the vManage is in cluster mode. That will not also be help, right?
Obviously.
Got it. Got it, sir.
Remember that only MSP will be managing those
Yep.
vManages.
And that customer of those MSP will not have that access to that vManage.
They might have access to the vManage, like kind of read only. And even if you want to provide them read write access, then provide read write access to the policies, to the templates, but not to the certificates, or maybe to the upgradation of the devices, like that.
Okay, means my intention is to get that clarification regarding if the
You will be
customer.
creating multiple tenants on vManage. There will be one tenant for one customer. Now, to your customer, you would be providing the tenant access. Customer will never be allowed to upgrade their control components by their own. Only MSP can upgrade them. If customer is looking, so ideally what MSP does, that they will let their customers know that today there is a activity schedule to upgrade the control components. Now, if control components have been upgraded and your managed routers are still running with lower version, that is not an issue. Managed routers can still be running with lower version. And later on, whenever your customer has some time, they can upgrade their managed routers by their own. And if MSP is doing everything for them, then MSP will be responsible to upgrade even their managed routers.
Clear, sir. Thank you. Got it.
Let's talk about the control plane now, which is obviously vSmart in this case. So as I told you that earlier, on a single router, we had control plane, management plane, and data plane. But now we have offloaded that functionality. The management plane has been offloaded as vManage. The control plane has been offloaded as vSmart. And yeah, the managed routers are still working as the data plane devices. They are still working in data plane. Right? So vSmart controllers are going to work as control plane. And since vSmart controllers are working as a control plane, that means that this control plane device will be responsible for best path selection. And then best path selection, best path information must be given back to the managed routers. Right? And also you can perform sort of route filtering, because it is having all of routes in its database table. So you can perform like route filtering or path manipulation. Right? You can change your topology, like you want to make hub and spoke, so that those policies will be implemented by the vSmart, because it is working as a control plane. And it has dramatically reduced the complexity of the control plane. Why? Because I don't know if you remember, yesterday I brought up this topic, right? Like if it is a traditional network, then all these managed routers in most cases at remote sites will be running MPLS and BGP, right? Border Gateway Protocol. If you wanted to modify your best path from one MPLS provider to another MPLS provider, you will have to log into each site router, and then you will have to modify the BGP policy, route policy, right? And that is a problem. Why? Because if you have got thousands of sites, then it will take so long time to get this done. Right? But since here in SD-WAN, you have got a centralized control plane, right? So you just have to make changes on this vSmart, and then it can affect all other remote sites, all the remote sites at same time. So it has reduced the complexity, but also it has increased the risk factor. If you are changing something on vSmart, it might affect all of your remote sites.